Hello everybody. So today we're going to be focusing on the idea of soil fertilization and kind of picking up where we left off in terms of talking about soil fertility and plant growth and the essential nutrients last time. So start off with kind of the easiest thing to talk about. Why would you do fertilization? Well, most elements are taken up, most elements that we want to be taken up by the plant. Basically, they get taken up by the plant, they get used, and then the plant dies, and when the plant dies, everything goes back into the ground. But when you have farming and you have crops and all of that, you're taking the crops and you're using the crops, so you don't get that same return. And so because you're not getting that same return, you just get a little bit of it. And because you get a little bit of it, you get this diminishing nutrient supply in the soil rather than the replenishment of nutrients in the soil. And so because of that, you need fertilization, because fertilization is going to correct your plant deficiencies and then also help you continue to get the yields that you're looking for, because you're still taking things out of the soil. And eventually, you take, and the soil's sitting there going like, hey, you need to give some because you're just continually taking. And so the ideal of fertilization is that you're finally giving back to the soil and trying to make up for what you've been taking out of it. And so what is a fertilizer? So a fertilizer is any material, whether it's organic or inorganic, natural or synthetic, that supplies plants with the necessary nutrients for plant growth and optimum yield. And so what are the things you need to know to fertilize? Lots of stuff, but really the biggest thing you want to think about is why are you fertilizing? So you want to make sure that you're fertilizing for a reason, and then that reason is known and understood, meaning you've already done the testing, which our book goes into a little bit of detail about. And you understand what it is that you're missing and why you're missing it and how much you need to put in. So that's what you're going to do, right? And you know what kind of crop you have, you know what kind of fertilizer you need to use, because you know what essential elements or nutrients you're missing, and then that's why you're going to fertilize. So we need to know the type of fertilizer, and then that's going to tell us our application rate, our timing, when would be best to do it, what kind of a method we're going to use. If I slide myself out of the way here, you can see. So if I'm doing a banded method as opposed to a broadcast method, it changes how I'm going to apply something. In this case, it's phosphorus. If I'm going to apply phosphorus banded, I want to leave it off to the side of the plant where it can be taken up by the plant roots, whereas if it's a broadcast, it's just going to be spread kind of all over the place and just going to be taken up by the soil, and it's going to have, some of it's going to be near the plant and some of it's going to be away from the plant. And then the location of where you're doing all these sorts of things and how you're going to do it, because it varies for place to place, especially understanding your soils and what your soils are, what's your pH and the different layers within your soils, those sorts of things all will affect rates of fertilization. So what are the goals and the concerns of fertility management? So we're looking to improve quality, especially if we're looking at fruits and vegetables. But I mean, really any crop, we're looking at improving quality. But when you think about fruits and vegetables, why do you say especially fruits and vegetables? Well, when you think about people in the grocery store, right? If you, some people are just throwing stuff in the carts, but you get to the fruit and vegetable aisle, all of a sudden everything's got to be pretty and everything's got to be perfect and everything's got to be big and look just exceptional. So that's why it's really important in terms of fruits and vegetables. Good nutrition is also important for things like disease resistance, drought tolerance, digestibility of forages, the sugar content, the general color and flavor. So it all matters, because when it's healthy, everything becomes easier. It's just like a person. When you're healthy, when you're in great shape, life seems easy. When you're not in great shape, lots of things seem hard, and it's the same thing for our plants. You definitely want to prevent environmental pollution. So that's your biggest concern. Your main potential problem is water contamination due to over-fertilization, and that can happen. Some of these we've talked about it, especially with the smaller secondary nutrients, and then the micronutrients that too much. You can get to too much real quick, and you can get to too little real quick. And it's hard to. You got to really make sure you hit that right amount. And too much can be a real problem, especially then if we're talking about the macronutrients. You get something like you over fertilize with nitrogen, and that starts leaching through the soils. That can be problematic. In terms of productivity, the larger the productivity, the potential, the larger the amount of fertilization required. So if you really think that you've got a really productive piece of land and you think you can really rev this thing up, I mean, you're going to have to, really fertilize and have a really strong fertilization program, because if you want it to live up to that potential productivity, you have to make sure that you get the right amounts in the soil, which means it's probably going to require large amounts of those macronutrients. So in terms of understanding fertilizer bags and fertilizer labels, so I've got a picture here of our fake little Grow Max fertilizer, but then you can see also this Scott's Starter fertilizer over to the right. And so the labels are always going to state the percentages of nitrogen, potassium, and phosphorus available in the bag, and it's always going to be in the order of nitrogen, phosphorus, potassium. It's always in the NPK order. So sometimes even if it doesn't say it, because it doesn't say it on either of these, but it says 10, 10, 10. So we're talking about available nitrogen, available phosphorus in the form of potash, and then available phosphorus. Sorry. My fault. Let's do that again. Available nitrogen, available phosphorus in the form of phosphate, and then available potassium in the form of potash. And we can see the same thing down here. So 20 is referring to the nitrogen, 27 is referring to the phosphorus, and 5 is referring to the potassium. You'll also see that they'll always have a net weight, and then the manufacturer. In this case, it's GrowMax. In this case, it's Scott's. When we're looking at the label specifically here, so 22, 3 and 14, so 22 nitrogen, 3 phosphorus, 14 potassium. Sometimes you'll get sulfur on there, but not always. The nitrogen is pure nitrogen. The phosphorus is phosphorus pentoxide or phosphate, even though chemically phosphate is actually is not P2O5. They just call it phosphate, mostly because it comes from rock phosphate, probably just the simplicity of that is what I would assume. And then your potassium is as potash. And then if you had if it had S in there, it would be pure sulfur, the same way it's pure nitrogen. And so how do we understand those numbers that are on the bag? So if we read this label and we read left to right, we read 1064. And so what we need to understand is that's talking about the percentage of each of those nutrients within that fertilizer. So it's 10% nitrogen, 6% phosphorus, and 4% potassium, or specifically 10% nitrogen, 6% phosphate, 4% potash. And so in just looking at that, you sit there and you go, okay, well, if that's 20%, what's the rest of it? So the rest of it's going to be the carrier or the soil that comes in the bag. Now, if we wanted to calculate the actual percentage of phosphorus in the phosphoric acid, that's about 44%. So you would multiply by 0.044 for whatever amount you got of your phosphoric acid or phosphate, and then that would get you to your actual amount of phosphorus in it. You can do the same thing for the potassium in the potash, which would be 83% or multiplying by 0.83 to get your potassium in there. And then, of course, we don't have to do that for nitrogen because it's pure nitrogen. So here's just a look at some just different ideas and how the numbers might change. So a starter fertilizer, which was similar to the Scott's example that we had a little while back, 18% nitrogen, 24% phosphorus, 12% potassium, whereas a lawn maintenance fertilizer now, you see much more nitrogen, much less phosphorus, about the same amount of potassium. You can have a zero phosphorus fertilizer, where you have plenty of phosphorus, so you see the 26, 0, and 10 there, and then you can have a general purpose or like an all-purpose fertilizer where you're going to get the same amounts of everything. So you might see 10, 10, 10. This example is 12, 12, 12, but you get just kind of the even amounts because you're not going for something specific. And so if we're doing fertilizer analysis, so we want to actually look at what it is exactly we're getting out of a bag. So let's take this bag of Greenview garden food. So it's a 5, 10, 5. So we've got our NPK. So that means 5% nitrogen, 10% phosphorus, 5% potassium, and it's a 40-pound bag. So if we do that, we can figure out some quick math. And so we can pull out calculators, but let's just kind of think about it simply. If we have 10% of 40 pounds, right? We just take 40 divided by 10, we have 4, right? So 4 pounds of phosphorus. Well, if I know that 10% of it is 4 pounds, then 5% of it is going to be 2 pounds, because that's just half of that. So if I do that, then I have my 5, 10, 5 combination. That means in my bag there's actually 2 pounds of nitrogen, there's 4 pounds of phosphate, and there's 2 pounds of potash. And so if I add all that together, that means there's 8 pounds of actual nutrients in my bag, which means the rest of the bag, because it weighs 40 pounds, is 32 pounds of carrier, 32 pounds of the soil that has the nutrients in it. And so what kind of things would we see that would make us think that that it's necessary to fertilize? And hopefully we don't get this far in areas, but maybe these are something to just really pay attention to make sure that we do avoid that. And we've talked about this stuff before, but if we have a phosphorus deficiency, you'll see reddish purple, particularly on young plants starting from the outside. If it's potassium, you're going to see the frying or the drying along the tips and the edges to where you get it to where it looks like it's going to kind of crumble apart. If it's nitrogen, you're going to be yellowing. That starts at the tip and then goes down the center, whereas potassium is on the edges. The nitrogen is the yellowing down the center. There's also magnesium, where you get the whitish strips along the veins. If it's drought, it's a lot more of the curling in the grayish green color. If it's some sort of disease, you might get spots or something, but this specific a little bit to corn, but there's you can see the same thing in other plants. And if you get like a chemical burn, then you'll get kind of the this more frayed look, and you get a little bit of the folding at the tips, and you get the white spots and other things. So just a little bit of a kind of a little look at some of the different ways that if you're missing an element, or if it's ways that we can tell it's not just an element thing, it's actually something else that's going on within our plants. So when do you need to apply fertilizer? And the most correct answer is close to when the plant needs it. So like for if we're talking about specifically nitrogen or a more focused nitrogen fertilizer, you really want to do it near the time of rapid growth and uptake. So your early growth stages, or in the fall when you kind of after harvest and all that, where you really kind of need to maybe replenish the soil, sort of a thing. When because the idea, if you think about it, the crops would be withering and dying, and then going back into the soil in the fall. Whereas that's not actually happening because we're harvesting all those crops, so you can apply nitrogen in that kind of same manner, because then that kind of mimics the natural pattern. In terms of if it's a fertilizer heavier to phosphorus or potassium, which you can get the specialized fertilizers depending on what it is that you need. That's much more flexible because they're not easily lost from the soil unless you have an area where you suffer from a lot of surface runoff. So you can really apply those at a variety of times. So what kind of fertilizers do we have? So specifically, if we're focusing on nitrogen fertilizers, you have anhydrous ammonia. Anhydrous just means without water. That's the most common commercial formulation locally. It's relatively cheap. It's applied by injecting into 6 inches into the soil. It can be hazardous, and you must use protective equipment, and that's also why it gets injected into the soil. Urea is the one that I was most familiar with, or the one that I just heard talked about the most. It's actually something that's part of urine. This is a synthetically made version. It's a slow release. It's very safe. That's probably why I heard about it much more than anhydrous ammonia. Urea becomes immediately available to plants once it gets put into the ground by converting to ammonia. It can be granular, and especially in lawns. That's the solid form. When we say granular, like little balls and stuff. Probably seen something similar to that in a lawn fertilizer, or it can be in a liquid form, but mostly granular form. At least that's what I've seen mostly. Here's kind of just a look. The idea of the anhydrous ammonia. So we said it's got to be injected into the soil. If you look here, so it's injected in, and it says expands as a gas as it's injected into the soil, where then it rapidly combines with the soil moisture. Here's a more broadcast application of fertilizer, and then over here, kind of a look at the fertilizers going in and what happens. So if we're using urea here, you get some of it going in, some of it volatilizes out. It turns into ammonium, gets used by the microbes in soil organic matter. It gets uptake by the plants. You get nitrification. You get some more plant uptake, but then you also get some denitrification. And if you have any runoff or erosion, you'd lose some that way. And then, of course, some is lost to leaching as well. And same thing happens with the other nitrate fertilizers. It gets converted to ammonium, and then the nitrification process. So just kind of an idea of how or what happens to the fertilizer in the soil. So 2 other versions of nitrogen fertilizers. You have ammonium nitrate, which that's the highest analysis for nitrogen, so 45% nitrogen by weight. Very rapidly available nitrate and ammonium held in the soil for later use. The one thing that's bad about ammonium nitrate is it's definitely used to make explosives, so it's not really sold much anymore. That's why it's not really as focused on as the other 2 are. And then there's also ammonium sulfate, which your book doesn't mention, but you also need sulfur for this. It's most used in a granular form, especially for non-commercial type of farming or gardening operations. It's a strong acid former, so it's great for our soils because out here we got the more alkaline soil, so it's not a bad thing to have it be a little acidic. So for your phosphorus fertilizers, phosphorus is taken up by the plant in smaller amounts than nitrogen and potassium. And if you need to fertilize with phosphorus, you must fertilize more than the amount is missing. So if you sit there and you do the testing and you figure it out and you say, you know, oh, I need you know, whatever, 40 pounds per acre of phosphorus, you need to put more than that into the soil because it's not in an available form, and so available form to the plants. And so because it's not in an available form, you need to put more of it because some of it's going to get to the plants and some of it's not. So you really have to kind of overdo it with phosphorus to actually get to the amount that you need. Phosphorus fertilizers usually come from phosphate rock, which is ground up, and it's the mineral apatite is the big it's the mineral that you get phosphate rock from, or it's the mineral in phosphate rock. About 32% phosphorus in terms of phosphate. Almost none of it is quickly available to the plant. That's what we were talking about earlier. It is cheap, but you got to send it for further refining. There's also phosphoric acid, which is a byproduct of the refining process with sulfuric acid, but is also sold as a fertilizer, usually in a liquid formation, and that's more closer to 40% phosphorus. And much of that, if you do it the phosphoric acid way, is immediately available to the plant. And so you can kind of just see this kind of figure here where it says phosphorus fertilizer can be absorbed by turf grass roots bound to soil particles. It is subject to runoff on compacted, bare, or frozen soils and recycled or removed during mowing. And so not big on mowing, not big on if you have compacted or bare soils, but good in a turf grass or a crop type of scenario. In terms of our potassium fertilizer, that's going to be mostly potash, which is potassium chloride, and you can see a picture of potash there on the right. It's absorbed by the plant roots, and that happens during cation exchange. And so what happens, because it's actually problematic if potassium chloride, if a large amount of it was actually taken up by the plant. And so what happens with potassium chloride is it's got to be taken in by the soil, usually because the clay and the organic matter have that negative charge that we talked about before. They can easily absorb the potash, and then through cation exchange with the plant roots, then the plant root gets it. Potash, we've said, is the number one fertilizer in the U.S. It's mined in the western U.S., especially in Utah and New Mexico. And so in looking at that, here's a potash mine. And, you know, I just kind of thought that this was a cool looking and an interesting process. Do I want to be in that mine? No, but I just think it's a really interesting process. And here's a look at a potash mining what do I want to say? Establishment or operation. That's the word I'm looking for. A potash mining operation near Moab, Utah. And if you want, you can pause and click the link here to see some other pictures of it. And then the last thing we really want to focus on is the idea of liming or of applying lime, which is in a fine powdery form. So you can see a pile of it here in this empty soybean field. So it's going to be spread out through the field in this fine form. And so let me move myself out of the way of my little chart here. So most crops thrive best in a slightly acidic soil. So we're talking about 6.5 to 6.8. So we're really talking about like right in here. That's when you really get down to it. That's where most crops really do best. And so when we're gonna apply lime, we're really focused on the idea of when we have these more acidic soils and we're trying to bring them back up this way. That's when we need to apply lime. So anything that's down in here, if it's down in here, it's probably not happening. But stuff that's over in this way, we want to bring it back up. And so lime, if we're applying lime, it's got 4 purposes. We want to neutralize soil acidity, so we want to raise the pH. So like we said, if we're over here, we want to bring it this way. If we're at 5.5, we want to bring it over here to 6.5, sort of a thing. We want to supply calcium and possibly magnesium as well to plants. That's in the lime. We also want to make other nutrient elements more available to plants by applying lime. That happens. And then also by applying lime, you're creating an environment that is optimal for soil microorganisms, which we know is a great thing. Anytime that the microorganisms are happy, the rest of the soil's going to be happy. So what should we aim for? So you can lime most crops to 6 or 6.5. So if we look at this chart here, you might have, your crops like down in this range or something. We want to get to 6 or to 6.5. Somewhere in there is going to be ideal. And the reason it's going to be ideal is because most nutrients are more readily soluble in that range, so they are ready to go if you can get to that pH. And then the beneficial microbes like the nitrogen-fixing rhizobia that we like so much, because we love that idea of nitrogen fixation and being able to convert nitrogen out of the atmosphere into a usable form. Those microbes are most active in that pH range from 6 to 6.5, that slightly acidic range. And so liming or applying lime helps us get to that. And that, I believe, is a nice, simple, short, and sweet soil fertilization explanation.